Good day, learners! Today, we will be describing properties of gases that will lead you to investigate the relationship between volume and temperature at constant pressure of a gas. One of the variables that affects the volume of a gas is the temperature of the gas and its surroundings. This volume-temperature relationship is quantified in Charle's law. In here, you will be introduced to another equation that determines the variation of gas volume with change in temperature. In 1787, Jacques Alexander Charle, a French physicist, performed an experiment using a balloon. Based on his observations, he discovered the relationship between the volume and the temperature of gases at constant pressure. This relationship was known as Charle's law. Charle's law states that when the pressure of a gas is kept constant, its volume is directly proportional to its temperature. This means that the volume of a gas increases as the temperature rises, and the volume decreases as the temperature drops. Charle's law can be written mathematically as volume is directly proportional to temperature at constant pressure. To remove the proportionality sign, a constant K is introduced. Then, volume over temperature is constant. If the same gas is brought to two different temperatures, it will give two different volumes. The equation will become V1 over T1 equals V2 over T2, where T1 equals initial temperature of a gas, V1 initial volume of the gas, T2 final temperature of the gas, and V2 final volume of the gas. In this lesson, you have to take note that among the units of temperature, we always express it in Kelvin. Thus, you need to convert Celsius value to Kelvin, which was named after Lord Kelvin, a Scottish physicist who has identified the lowest attainable temperature, known as the absolute zero, with a value of -273. To convert Celsius to Kelvin, you have to use this equation. Kelvin equals degrees Celsius plus 273. For example, you have to convert 10 degrees Celsius to Kelvin. 10 degrees Celsius plus 273 equals 283 Kelvin. The following are the temperature conversion formulas. Celsius to Fahrenheit, Kelvin to Fahrenheit, Fahrenheit to Celsius, Celsius to Kelvin, Kelvin to Celsius, Fahrenheit to Kelvin. Okay, learners, consider these sample problems involving Charle's law. A party balloon is filled with 3 liters of helium gas at 27 degrees Celsius. The balloon is then left in a place where the temperature is 43 degrees Celsius. Assuming that the balloon does not burst and the pressure is unchanged, calculate the new volume of the helium. Again, we have to identify the given data. V1 equals 3 liters, T1 equals 27 degrees Celsius, plus 273 equals 343 Kelvin. The equation is V1 over T1 equals V2 over T2. Here, we do the cross multiplication, then divide both sides by T1. Solving for the final volume, we have 2.76 liters. Okay, here is another problem. At 45 degrees Celsius, a certain mass of nitrogen gas occupies a volume of 50 cubic meters. If there is no change in the pressure, predict the temperature in Kelvin needed for the same mass of nitrogen gas to occupy a volume of 60 cubic meters. Here we have to identify the given data. T1 equals 45 degrees Celsius plus 273 equals 318 Kelvin. V1 equals 50 cubic meters. T2 is unknown. V2 equals 60 cubic meters. The equation is V1 over T1 equals V2 over T2. Again, we do cross multiplication. Then divide both sides by V1. Solving for the final temperature, we have 381.6 Kelvin. Okay, learners, can you follow? Here is a simple activity demonstrating Charle's law. Press a ping pong ball until it becomes dented. What would you do to a ping pong ball which is out of shape or crushed? Now, put them in a bowl with hot water. What is your observation? When you let the ping pong ball float on hot water, the temperature of the air inside the bowl also increases, which in turn leads to an increase in the volume of the gas. Therefore, the shape of the ball is restored. Direct application of Charle's law can be seen in such equipment as an incubator. When air comes into contact with the heating element, it expands and becomes lighter. This lighter air rises, causing the circulation of warm air throughout the incubator. Charle's law is an experimental gas law that describes how gases tend to expand when heated and contract when cooled. Through the experiments of Jacques Charle, the volume of a gas increases with an increase in the temperature. Shrinking of an inflated balloon and a bicycle tire in a very low temperature show the decrease of volume, which explains that the relationship of volume and temperature is directly related at constant pressure. Now, can you enumerate familiar events you observe in your community and household which are related with the volume-temperature relationship in gases? Now, this is your assignment. Okay? That's all for today. Thank you very much.